The modern internal combustion engine is a marvel of microscopic precision, a high-heat, high-pressure environment where timing is measured in milliseconds and tolerances are measured in microns. At the very center of this mechanical symphony sits the fuel injector, a component so vital yet so frequently misunderstood by the average vehicle owner. We often take for granted that when we press the accelerator, the engine will respond with immediate power, but that response is entirely dependent on the injector's ability to atomize fuel into a perfect, misty levee. Over thousands of miles, however, a silent enemy begins to form inside these precision instruments: carbon deposits, varnishes, and gums. This phenomenon, often accelerated by the heat soak that occurs every time you turn off your engine, causes the residual fuel on the injector tips to bake and harden into a crust. This crust disrupts the spray pattern, turning a fine mist into a jagged stream or a sluggish drip. This leads to a cascade of engine problems, including rough idling, hesitation during acceleration, increased emissions, and a drastic decline in fuel economy. Today, we are going to explore the 9 definitive ways to clean these injectors without ever removing them from the engine block. We will move past the superficial advice found in most manuals and dive deep into the chemical engineering of detergents, the physics of high-pressure cleaning, and the maintenance strategies that separate a 200,000-mile engine from a 50,000-mile failure. To truly appreciate why these methods work, we must first recognize that an injector is essentially a high-speed electromagnetic valve. When the ECU sends a signal, a solenoid lifts a needle off its seat, allowing pressurized fuel to escape through tiny orifices. If these orifices are even partially obstructed by a layer of carbon no thicker than a human hair, the volumetric efficiency of the cylinder drops, the air-fuel ratio becomes lean, and the engine's knock sensors begin to retard timing, stealing your horsepower and your money. By understanding these non-invasive techniques, you can restore your vehicle's factory performance, save thousands in repair costs, and ensure that your engine breathes as cleanly as the day it left the assembly line. The first and arguably most scientifically validated method for cleaning injectors from the inside out is the use of high-concentration additives based on polyetheramine, commonly referred to in the industry as PEA. To understand why PEA is the nuclear option of fuel additives, we have to look at its molecular structure. Unlike standard detergents like alcohols or simpler amines found in cheap gas station boosters, PEA is a nitrogen-based cleaning agent designed for extreme thermal stability. Most additives burn up the moment they enter the combustion chamber, meaning they might clean the fuel lines but do absolutely nothing for the injector tips or the valves. PEA, however, survives the intense heat of the explosion, allowing it to chemically bond with hardened carbon deposits at a molecular level. It essentially liquefies the rock-hard carbon, breaking the chemical chains that hold the soot to the metal surfaces. Once dissolved, these deposits are carried into the cylinder and burned off during the normal combustion cycle, exiting through the exhaust as harmless gases. This method is the ultimate starting point for any car owner noticing a dip in performance because it requires zero mechanical skill. You simply pour the concentrated bottle into a near-empty tank and fill up with high-quality fuel. The key here is the soak time. The longer the treated fuel remains in the system and cycles through the injectors, the more layers of carbon it can peel away. It is not just a cleaner, it is a restorative treatment that polishes the internal needles and seats of the injector, ensuring that the flow remains laminar and the atomization remains perfect even under high load. This process is particularly vital for modern engines that utilize gasoline direct injection, as the temperatures at the injector tip can exceed several hundred degrees, causing carbon to bake on much harder than in older port-injected systems. Before we proceed into the second chemical strategy, I want to stop and ask you a question regarding your own maintenance routine. Given the high cost of fuel these days, have you ever noticed a specific brand of gasoline that seems to make your car run smoother? Or do you always go for the cheapest option at the pump regardless of the brand? Let me know in the comments below, as this choice is often the primary factor in how fast your injectors begin to clog. Moving to our second method, we must discuss polyisobutylene amine, or PIBA, which serves a distinct but equally important role in fuel system hygiene. While PEA is the heavy hitter for deep cleaning, PIBA is the essential tool for ongoing maintenance and the prevention of soft deposits like gums and varnishes. These deposits are particularly prevalent in regions where ethanol-blended fuels are the standard. Ethanol is hygroscopic, meaning it attracts water from the atmosphere, and when fuel sits in your lines or your tank, it begins to oxidize and form a sticky, amber-colored residue. This residue acts like a glue, slowing down the movement of the injector's internal solenoid and preventing the needle from sealing perfectly. PIBA works by reducing the surface tension of the fuel, creating a slick environment that prevents these hydrocarbon molecules from grouping together and adhering to the metal walls of the fuel rail or the injector body. It is particularly effective for older port injection engines where fuel is sprayed over the intake valves. By using a PIBA-based maintenance cleaner every few thousand miles, you are essentially waxing the internal plumbing of your engine, ensuring that the fuel delivery remains crisp and that the computer's fuel trims remain within their optimal parameters. It is the difference between a system that is constantly fighting against internal friction and one that operates with effortless efficiency. Furthermore, PIBA acts as a corrosion inhibitor, coating the steel components of the fuel rail to prevent rust particles from forming and migrating into the injector's microfilters, which is a common cause of total injector failure in vehicles that are driven infrequently. Our third method transitions from simple tank additives to a more professional, hands-on DIY approach: the pressurized fuel rail cleaning kit. This is the most effective way to clean injectors without removal because it completely removes the dilution factor. When you put an additive in your tank, it is mixed with 15 or 20 gallons of gasoline, which weakens its chemical strength. A rail cleaning kit, however, bypasses the fuel tank entirely. To perform this, you must first disable your fuel pump by pulling the fuse or relay so that no gasoline comes from the tank. You then connect a specialized canister directly to the fuel rail's Schrader valve, which looks like a tire valve, and fill that canister with a high-pressure professional-grade cleaning solvent. You then use compressed air to pressurize the canister to the engine's exact operating specifications. When you start the car, the engine runs exclusively on the cleaning solvent for 15 to 20 minutes. This provides a concentrated chemical bath to the injectors. The solvent is formulated to be highly aggressive toward carbon but safe for seals and gaskets. Because the engine is running on pure cleaner, the injectors are forced to pulse this high-strength liquid through their internal filters and nozzles at full speed. This process frequently clears blockages that would take 10 tanks of gas additives to solve, restoring a dead or misfiring injector to perfect health in a single session. It is the service that dealerships charge hundreds of dollars for, yet with a one-time investment in the tool, you can achieve the same results in your driveway. The primary advantage here is the removal of varnish lock, where the injector pintle becomes so sticky that it cannot move at the high speeds required for modern stratified charge combustion. We are moving into more technical territory now, involving direct manipulation of the engine's fuel rail. I am curious about your comfort level with this kind of work. Would you feel confident disabling your fuel pump and hooking up a pressurized canister to your engine, or does the idea of working with pressurized chemicals make you prefer the pour in the tank methods? Share your thoughts below, as it helps me understand what level of DIY instruction you need. The fourth method is the vacuum induction cleaning process, which is critical for cleaning the external tips of the injectors and the surrounding intake architecture. In many modern engines, especially those with gasoline direct injection, the injectors are located inside the combustion chamber. However, the airflow leading to them can be disrupted by gunk in the intake manifold. This method uses the engine's own vacuum, typically through a brake booster line or a dedicated vacuum port, to sip a specialized liquid or foam cleaner while the engine is running at a fast idle. As the cleaner is sucked into the manifold, it turns into a mist that coats the intake valves and the exterior of the injector nozzles. This is particularly important because carbon often builds up on the exterior of the injector tip, creating a chimney or coking effect that distorts the spray levy before it even enters the cylinder. The vacuum induction method uses a thermal shock effect. The relatively cold cleaning liquid hits the hot carbon on the valves and injectors, causing the carbon to crack and flake off. These flakes are then safely incinerated in the combustion chamber and expelled through the exhaust. This method ensures that the environment the injector is spraying into is just as clean as the internal passages of the injector itself, allowing for a more homogeneous air-fuel mixture and a more efficient flame front. This is often the missing link in restoring a smooth idle to a vehicle that has already had its fuel system treated with tank additives, as it addresses the mechanical obstructions in the air path that additives simply cannot reach. Method number 5 involves the preventative strategy of exclusively using top-tier detergent gasoline. Many drivers believe that all gasoline is the same because it all comes from the same pipelines, but this is a dangerous misconception. While the base fuel may be identical, the additive packages mixed in at the distribution terminal are not. Top tier is a performance standard established by major automakers because they realized that the minimum legal requirements for fuel detergents were not sufficient to protect modern engines. Top-tier fuel contains a much higher concentration of deposit control additives that act as a continuous, low-intensity cleaning cycle for your injectors. Every gallon of top-tier fuel that passes through your system is actively scrubbing the metal surfaces and preventing the initial seeds of carbon from ever taking hold. It is a cumulative strategy. Over 50,000 miles, an engine run on top-tier gas will have significantly cleaner injectors and valves than one run on minimum requirement fuel. This is the easiest way to clean your injectors because it requires no extra time or tools, just a conscious choice at the pump to support the engineering of your vehicle rather than just looking for the lowest price. It's also worth noting that top-tier fuels often contain better moisture-fighting additives, which prevent the phase separation of ethanol and water that can lead to corrosion inside the injector's delicate armature. Since we've just discussed the long-term impact of choosing high-quality fuel versus the cheapest option, I'd love to ask, have you ever had a mechanic show you a dirty part from your engine, like a spark plug or a valve, and tell you that bad gas was the culprit? It's a common diagnosis, but I want to know if you believed them or thought it was just an upsell. Let's talk about that in the comments. The sixth method is a classic technique often referred to by mechanics as the Italian tune-up. While the name sounds like a joke from a bygone era, the physics behind it are incredibly sound and relevant for modern injectors. This method involves driving the vehicle on a highway for a sustained period, usually 20 to 30 minutes, while keeping the engine at a higher RPM than usual, typically between 3,000 and 4,000 RPM. The goal here is thermodynamics. In stop-and-go city traffic, the engine never reaches a high enough sustained temperature to self-clean. By running the engine under load at high RPMs, you increase the internal temperature of the combustion chamber to its maximum safe limit. This intense heat causes a process called pyrolysis, where softer carbon deposits on the injector tips and piston crowns are literally baked into dust and blown out the exhaust. Furthermore, the high velocity of fuel flowing through the injectors at high RPM creates a mechanical scrubbing effect. The fast-moving fluid helps dislodge any loose debris that hasn't yet hardened into solid carbon. If you combine an Italian tune-up with a high-quality PEA additive in the tank, you create the perfect storm for injector cleaning. The chemical breaks down the bonds, and the high-speed thermal load blasts them away. This is especially useful for older vehicles that have become sluggish after years of short, low-speed commutes. Our seventh method focuses specifically on the needs of modern gasoline direct injection engines, which require specialized aerosol intake cleaning. As we mentioned, GDI engines are notorious for carbon buildup because the fuel is sprayed directly into the cylinder, meaning the intake valves never get washed by gasoline. This allows oil vapor from the crankcase to bake onto the valves and the injector tips. To clean these without removal, you use a high-pressure aerosol spray with a long, flexible straw that is inserted into the air intake past the mass airflow sensor. With the engine running at about 2,000 RPM, you spray the aerosol in short bursts. The chemical is specifically formulated to be sticky, so that it clings to the carbon on the injectors and valves long enough to penetrate the hard outer shell. This is a critical maintenance step for any car built in the last 10 years, as GDI carbon buildup buildup can lead to pre-ignition or low-speed pre-ignition, LSPI, which can literally crack a piston. By using this aerosol method every 15,000 miles, you ensure that the high-pressure spray from the GDI injector isn't being blocked by the massive carbon forests that tend to grow in these modern engines. This method essentially cleans the face of the injector that is constantly being assaulted by the soot and heat of the combustion cycle. The eighth method is tailored for diesel engines, the use of common rail system cleaners with lubricity enhancers. Diesel injectors are vastly more complex than gasoline injectors, often featuring piezoelectric actuators that can pulse 5 or more times per single combustion stroke. Because diesel fuel itself acts as the lubricant for the high-pressure pump and the injector internals, any lack of lubricity leads to physical wear and stiction, where the injector needle gets stuck. Cleaning diesel injectors without removal requires a purge method. Similar to the gasoline rail cleaning, you disconnect the fuel supply and return lines and run the engine directly off a can of concentrated diesel purge. This fluid contains high-strength detergents to remove soot and varnish, but more importantly, it contains concentrated lubricity agents that coat the precision-machined needles. This is vital for engines running on modern ultra-low sulfur diesel, which is drier and more prone to causing injector wear. A diesel purge can instantly quiet a clacking engine and restore the smooth, rhythmic idle that signifies a healthy common rail system. It also helps to clear out the microscopic sulfur deposits that can form on the injector nozzles, which are much smaller and more prone to clogging than their gasoline counterparts. As we approach the final and most advanced method, I have a question for the diesel owners, or those considering a modern turbocharged vehicle. Were you aware that these engines require specialized lubrication additives in the fuel to prevent the injectors from physically wearing out? Or is this the first time you've heard of lubricity as a factor in fuel system health? Let me know, because this is the #1 reason for diesel injector failure. Finally, the ninth method is the use of professional-grade induction machines, often referred to as a TerraClean or motor vac service. While this technically requires a visit to a specialized shop, it is still a without removal method that represents the pinnacle of injector care. These machines are sophisticated computers that hook into your fuel system and create a closed-loop cleaning circuit. They don't just use one chemical, they often use a multi-stage process. The first stage uses a solvent to dissolve surface gums, while the second stage uses a different chemical that reacts with the heat of combustion to create a steam cleaning effect inside the cylinder. Some of these machines even use harmonic vibrations, sending specific frequencies through the fuel lines to help physically shake loose the carbon molecules from the injector pinnals. This is the nuclear option for a vehicle with very high mileage that has failed its emissions test or is running so poorly that standard additives have had no effect. It is a comprehensive, whole-system detox that cleans the injectors, the combustion chamber, the oxygen sensors, and even the catalytic converter in one single, high-tech procedure. The benefit of this machine-based approach is that it can monitor the engine's vacuum and exhaust gases in real time, adjusting the flow of cleaning chemicals to ensure the most thorough cleaning without damaging the engine's sensitive internal components. To wrap up this extensive guide, it is important to realize that fuel injector health is not a one-time fix but a philosophy of vehicle care. The 9 methods we have discussed, ranging from the chemical simplicity of PEA additives to the technical precision of common rail purges and harmonic induction machines, all serve a single purpose: maintaining the perfect atomization of fuel. When your injectors are clean, your engine is more efficient, your throttle response is crisper, and your long-term ownership costs are drastically reduced. You don't need to be a professional mechanic to take control of your fuel system's hygiene. By starting with preventative measures like top-tier fuel and periodic PEA treatments, and moving to more aggressive methods like rail cleaning kits as your mileage increases, you can effectively freeze the aging process of your engine. Your car is an investment, and the fuel injectors are the gatekeepers of that investment's performance. Treat them with the respect they deserve, and they will reward you with hundreds of thousands of miles of reliable, powerful service. Whether you are driving a high-performance sports car, a rugged diesel truck, or a modern family SUV, the science of cleaning without removal is your best defense against the inevitable accumulation of carbon in the modern world. It is also vital to consider the economic impact of clean injectors. If a clogged injector reduces your fuel economy by just 10%, a very conservative estimate for a dirty system, you are effectively throwing away hundreds of dollars a year at the gas pump. Over the lifespan of a vehicle, this adds up to thousands of dollars in wasted fuel, not to mention the eventual cost of replacing a ruined catalytic converter that was choked by unburned fuel. By spending $30 on a high-quality PA additive or $100 on a pressurized rail cleaning tool, you are making an investment that pays for itself within months. Furthermore, clean injectors ensure that your engine's emissions stay within legal limits, protecting the environment and ensuring that you don't face expensive fines or failed inspections. Most people ignore their fuel system until the check engine light comes on, but by then, the damage is often physical rather than just chemical. The proactive owner knows that a clean spray pattern is the secret to a smooth, quiet, and powerful driving experience. We often focus on oil changes and tire rotations, but the fuel system is the circulatory system of your vehicle. It deserves just as much attention and care. As we reach the conclusion of this deep dive, I want to leave you with one final thought and a question. Now that you've seen the science and the methods, which one of these 9 strategies will you be implementing on your car this weekend? Is it the simple tank additive, the highway Italian tune-up, or are you ready to buy a rail cleaning kit and do it like a pro? Leave your plan in the comments below, and let's start a conversation about keeping our engines alive and well. As we finish this ultimate guide to fuel system maintenance, I hope you feel empowered to take charge of your vehicle's health. The internal combustion engine is a resilient machine, but it requires clean fuel and clear pathways to do its job. Whether you're trying to eke out a few more miles per gallon or trying to restore the lost roar of a performance engine, these 9 methods offer a clear roadmap to success. Don't let carbon buildup steal the performance you paid for. Take action. Choose the method that fits your skill level and enjoy the feeling of an engine that runs as smoothly as it did the day it left the showroom. There is a special kind of satisfaction in knowing that you've extended the life of your vehicle through smart, science-based maintenance. Keep your filters fresh, your fuel clean, and your injectors spraying perfectly, and your car will take care of you for many years to come. I have one final question for you to consider. Based on the 9 methods we've explored today, which one do you feel is most practical for your current vehicle and maintenance budget? And would you like to see a follow-up video where I demonstrate the pressurized rail cleaning process step by step? Let me know your thoughts and your planned strategy in the comments below. Don't forget to like and subscribe for more in-depth automotive guides, and I will see you in the next one. Thank you for joining me on this technical journey through the heart of the engine.